Hi everyone, and welcome back after the break, where we now have the pleasure to hear a presentation from Daniel Haefliger, who is the CEO of Sateco Group, and he will tell us a bit about molded elastic sensors today. Daniel, with that, over to you. The stage is yours.
Thank you very much for the introduction. So in the next few minutes, I'd like to introduce you our developments in molded elastic sensors. So why are we looking into these type of sensors? So basically, we see today a trend in the industry towards compliancy for, let's say, mechanical compliancy. So we want to fit the machine to the human body and the human behavior and not the other way around. We also want to have interactions with machines which are natural, intuitive, and we also need technology which can be integrated quite simply into a very complex device, because today we'll also have a high mix of materials in many new machines. So and all this basically creates a need for soft and flexible materials that can adapt to the surface shape. Ideally, they're also friendly to skin and food, and they can be completely shaped in 3D according to ergonomic needs. A few words on the silicone force sensor itself. So what is it? Basically, it's a molded elastomer sensor. Unlike many sensors which are based on printed electronics, we're using a molding process. I'll come to this later. The sensor is a capacitive type sensor. It works according, it's like a built-up capacitor, and it can be used for force or pressure sensing, but also for proximity sensing or so-called touch sensing. Why do we use do we design it like this? So it is a soft material. It is a resilient material, so it can withstand shocks quite easily, and it contains no metals. The key markets that we are promoting this technology is basically for our home market in automotive interiors, but also furniture, robots, automation technology, medical technology like in prostheses, gaming, and safety equipment. So a few words about the working principle and the design shape or size of that device. So basically, typical dimensions so that you get a feeling about the sensor and the technology. So typical size is between 10 and 40 mm. Thicknesses is 3 millimeter and thicker, so it's more bulkier in a way than a printed sensor. Typical measurement range is usually in the range of maximum 10 Newton to 100 Newton, depending on design. The travel in direction of the force, so in vertical direction, is around 1 millimeter or even more if needed. And the resolution is roughly around 0.1 Newton, always depending on the design, the size, and so on. So by saying this, actually all the specifications are usually also subject to optimizations and applications. So because we're using a molding technology, we can also adjust the size, shape, and also the performance of the sensor, depending on the use case. Electrical contacting is usually done via connectors. That can be a crimp contact, connectors, or you can simply clamp in the sensor. So the following movie gives you a short overview on how the sensor is built up, the working concept, and also how it works.